In my last videos, I showed you how I built a solar panel on the rooftop of my van. In this video, I'll show you how I built the battery pack. I'm also going to show you how to charge it with a solar charge controller. And finally, we'll show you how to pull power out of the battery using an inverter. Let's get started. First of all, let's talk about the inverter. This is the most important part of your system. You might think the battery is the most important part, but it isn't. The battery is the most expensive part of the system, not the most important part. That's because you can configure the battery to run on different voltages. On the other hand, you cannot change the parameters on an inverter. So if your inverter is 12 volt DC, you must run it at 12 volt DC. There is no other way and there's nothing you can do about it. Unless you buy a new inverter, of course. Therefore, the inverter determines the voltage of the entire system. This is where you should start your project. The inverter dictates the voltage of your battery, and from that, it determines the voltage of your charge controller and ultimately the voltage of your solar panel. In this case, my inverter is 36 volts, so I have to use a 36 volt battery pack. And because the battery is 36 volts, I have to use a 36 volt charge controller to charge it. This inverter is actually a UPS power supply. Inside this unit, there used to be 3 12 volt lead acid batteries. These batteries only last for a couple of years and then they died. The owner got tired of it and gave it away. So I got this inverter for free. I removed the lead acid batteries and soldered an XT60 connector so I can hook up my 36 volt battery to it. I also got rid of the AC cable that plugs into a 120 volt AC outlet because I don't need it to be plugged in anymore. I'll use a solar panel to charge the batteries instead. This UPS power supply is fine to be used as an off-grid inverter. When I turn it on, it will beep continuously indicating that it's running on battery power, but there's a mute button, so every time I turn it on, I just have to press this mute button to stop the beeping. This inverter is a square wave inverter and it's not a pure sine wave inverter. A pure sine wave inverter is ideal, but it's very hard to find and it's a lot more expensive. But I only use it on the van, on the road, so this should work fine for that purpose. On the back of the inverter, I install a fuse switch. It's actually a disconnect with a fuse. And this is what it looks like. It's made by Ferraz Shawmut. It's a very useful fuse switch and I use this a lot for my projects. And this is the off position. That's on. And it's got a space inside so you can install a fuse. This is the fuse that I used. It's a 30 amp fuse. So it goes in here. And then push it down. You can turn it on. Now it's on. It's connecting this terminal on this side with this terminal on this side. It's very easy to use and it's very useful. The battery I'm using for this project is a pack of 5 Nissan Leaf battery modules connected in series. Each module is rated at 500 watt-hours, so 5 of these will give me a total of 2.5 kilowatt-hour of power. Inside each of a Nissan Leaf battery module, we got 4 individual lithium-ion cells connected in a 2S2P configuration. So when I put 5 of these modules in series, it's actually a 10S2P configuration. Each cell is recommended to be charged at a maximum 4.1 volts. You can charge it up to 4.2 volts per cell, but the battery life will be compromised. So for my 10S battery pack here, I'll charge it at 4.1 volt per cell or 41 volt maximum for the entire pack. Each module is rated at 7.6 volt nominal, so 5 of these will be exactly 38 volts nominal. And at full charge, this pack of 5 in series will be 41 volts, which is perfect to run my 36 volt inverter. The inverter operating voltage range is from 30 volts to 42 volts DC. And let me show you how I connect all of these together. Each battery module got 4 holes on 4 corners. This here, and 2 on the other side. And I use a very long bolt, and this bolt is called carriage bolt. And I use 4 long bolts to connect all 4 corners together and bolt them together. On each module, it's got a positive and a negative terminal, and I use a original Nissan Leaf bus bar to connect them all in series. And this one here, I only have 3, And this one here, I made it myself using a copper pipe and just drill 2 holes, and that's it. Over here on this side is the positive terminal of the entire battery pack. That is a negative terminal, and on each terminal I install 2 wires. One wire goes to the charge controller. This wire is thinner because there's not a lot of current going through this wire, because my solar panel, I only have one solar panel and it only has less than 10 amp of current. The other wire is thicker because it goes through the inverter, and it's size 10, it's rated at 30 amp. This way I can charge and discharge the battery at the same time. So this wire is power coming in from a charge controller. That wire is power going out to the inverter. Let me show you how I insulate this terminal to prevent it from shorting out. So I cut pieces of foam and slide it in the gap. And then I cut another small piece of foam and put it right on the top. And then I'm going to use tape and tape it over. And that's it. Very simple but effective. Let me show you my solar charge controller. It's actually a boost converter. That's because my solar panel is only 30 volts, whereas my battery is about 40 volts. So I need something to boost up the voltage. So this wire here goes to the battery, and this wire here will go to the solar panel. I also install a fuse, a 10 amp fuse, inline fuse. And it also acts as a disconnect switch if I want to disconnect the solar panel from the charge controller. Just pull this out and it's disconnected. So next we're going to go inside the van. I'm going to show you how I put everything together. So over here, the center console is where I'm going to put my inverter, and it's going to fit in here nicely. I also need to find a way to secure this inverter down, because last time I was using it, I was driving on the freeway and I stepped on the brake, and then all of a sudden the inverter flew forward and hit the gear lever and pushed it to neutral, and that was quite dangerous. And my solution is quite simple: bungee cord. So already have some pre-drilled holes on the side of the inverter. So all I gotta do is to hook it up to one side, loop it around down, and then hook it on the other side, and boom, it is tight. It's not gonna go anywhere. Because I only secure on the back of the inverter, and this will prevent it from flying forward. Does not prevent the inverter from flying backward. But I don't drive like Michael Schumacher, so that's not something I would worry about. Alright, so on the top of the center console I have the inverter, and on the bottom there is just enough room to install my battery pack in there. So here we go. The solar charge controller is going to be conveniently going inside the bottom part of the inverter, just like that. So I've got this wire which comes from the solar panel on the roof of the van. It's going to go to the charge controller like so, and from the charge controller this wire is going to go to the battery pack, which is this wire from the battery pack. See the spark every time. Now we can connect the wire from the inverter, which is this wire, to the battery. Okay, there's no spark because my switch is off. You can see the inside The switch is currently off. Now I can press it down, turn it on. There'll be no spark produced. That is pretty much it. And this is what it looks like from the back. After I tidy up the wires, everything looks nice and neat. So I took this for a camping trip 1,000 miles away, and it works like a charm. Overall, this solar panel works great for what we're using. I have enough power to charge cell phones, camera batteries, walkie-talkie batteries, all kinds of batteries. We have enough power to turn on the lights at night and even cook some food. On average, I get about 1 kilowatt-hour of power per day coming from the solar panel if I park the car the whole day in the sun with no shading. So currently my solar panel is 250 watts, and I just got a higher wattage panel which is 327 watts. I'm thinking about upgrading to a bigger solar panel, but that's going to be on a different video. Until then, thanks for watching. See you next time.